This mic?
Roy's checking that mic. I
This
think it
mic
should
is
all be
being
good.
checked right now. Randy, can you hear me?
It was very clear.
Perfect.
Thank you. Yay, technology's fun. So, hello everybody. This is the first session on the Sunday, so it's before the meeting has even started. So we will vamp for a little while in case anybody else wants to wander in. That seems like enough vamping. So, hello everybody. Welcome to IEPG at IETF 121. Also, thank you to everybody who sort of showed up when I was like, help, panic, we don't have enough presentations. And lots of people provided presentations. So thank you, everyone. We now have a relatively full agenda, but it was a little bit touch and go for a while. I'm assuming everybody here already knows what the IEPG is, but this is what it is. And you're all here presumably for a reason. So hopefully this is interesting. This is our current agenda. We now also have a bonus presentation from Philip Baker. Somehow I hadn't seen an email from him, so we've added him at the end. Thank you, Philip. And the agenda is also the Swisscom one actually is two separate presentations. I only listed it as one because I didn't have the title for the second. So with that said, I will get Roy's slides up. Oh, does anybody care their order? Does anybody want their order changed? I don't think anybody. Yes, will you let him know that I'd originally told him it was likely to be around 10:50 to 11, if you can poke him on chat. Yeah, he's at a different meeting at the moment. So yeah, if you can let him know that we've put him towards the end, that would be great. 11:20 or 11 between 11:20 and 11:40. Math is hard. Math's hard. Let's go shopping. Indeed. So first up, we have Mr. Roy. Okay, there it is. Confirm your selection. And as always, let me make sure that the slide clicker does things. Yay. Take it away, Roy.
I don't think that's it. But...
Fuck.
I don't mind.
Do you want to talk about those slides? There we go. Off by one error. Perfect.
Perfect. Thank you, Warren. My name is Roy Adams. I work for ICANN. This is a recycled talk that I gave last week at the DNS working group in Prague. So if I could get a raise of hands, who have seen this last week in Prague? All right, so this is the time to check your mail and do something else, and don't give it all away. So this is basically a talk about what can happen when you configure a name that doesn't belong to you. This is RC 2606, and it talks about reserved top-level domains. And it talks about things like tests that you can configure to test your code, to test your local DNS code, etc., etc. And it comes with this warning. Without guidance, a site might set up some local additional unused top-level domains for testing of its local DNS code and configuration. And later, these top-level domains might come into actual use on the global internet. And you can see why that is a problem. But the good thing in RC, I forgot which RC, but John Pastel already forewarned in 1994, 1995, that it's extremely unlikely that more top-level domains would be allocated. Everyone remembers 2012, the avalanche of new top-level domains. However, we already had a few before then, 13 before then, and over 1,000 since 2012. And the reason I'm mentioning the date 2012 is because at that time people were very busy trying to understand what will happen if you have a name collision. And the ASSEC, and most of you know it, but I'll repeat what it is. The ASSEC is an advisory committee within the ICANN community that advises the board of anything related to security and stability. And they wrote many documents, and these are just 3 of them. ASSEC 57, 62, and 66. All of them related to name collisions. And ICANN wrote a blog about this with a lot of resources regarding name collision. Since then, ICANN has started also by initiation of ASSEC, the Name Collision Analysis Project, NCAP. And meanwhile, at an ICANN DNS symposium, this was in Bangkok in 2019, a good friend, Alexander Meyerhoven from NIC AT, gave a presentation and was named DNS Magnitude. And it did something interesting because until that time, I was counting queries, right? And you would measure things by the most amount of queries it would get. Now, of course, if you're in DNS, you know that you can play with these things. Like if you change the TTL to somewhat lower, you get more queries. So that's not really a fair measurement for popularity. And I thought that what Alexander said, that was a little bit more fair. I mean, it's also a lot harder to count hosts than queries, unique hosts and queries. So the idea behind this was basically, if you have 100 people asking for example, right? That's in some sense more popular than one person asking for .example 100 times. All right, I hope that makes sense. We thought it was a good idea, so we talked to NIC AT, and they wrote this fantastic paper. It's really interesting. It's a well done academic paper actually, and I know this because I'm not part of the authors. So, but and we also decided to apply this almost every. The reason I say almost, it will become clear in a second. We apply this every day to L-route traffic data. And we get something like this. So this is a page. This was generated on the 27th of October. For the 21st of October, there's a 6-day delay. Now, I really like to say that the 6-day delay is to make sure that script kiddies don't see an immediate effect when they try to send a lot of traffic to the root server. But the real case is it gives me time to fix my broken code and get it to update before anyone else sees it. So yeah, I look at this every day. And not because I'm really impressed with my own work, it's really because it sometimes falls over. And I thought it fell over when I looked on around the 21st, around the 15th, 14th of May. What you see here is, I need to wear my glasses for this, sorry. What you see here is S-Cloud. And S-Cloud is now number 17 on the daily rank. The daily rank, oh, thank you, Warren. The daily rank would be the fourth column, I think. 1, 2, 3, 4. Yeah, the daily rank is the fourth column. Now, on the left-hand side, you see magnitude value, and these things are calculated with a log scale. That means that if you want to go from, let's say, 100 to rank 10, you need to do an enormous amount of work to get there. Right? It's not just linear, this is a log scale. And you can see that, for instance, COM has about 1 million unique sources, and .scloud below is 211,000. Now, when I say unique sources, these are not IP addresses. These are networks. These are /24s for IPv4 and /48s for IPv6. And we've done the hard work. We've also counted individual hosts. And it turns out that it doesn't influence the ranking, at least not in the top 250 at all. I don't know why that is. I can't prove it, but at least for 365 days in a row, the top doesn't change at all. If it would change from day 1 to day 2, then the individual host ranking would also change change the same way. So anyway, S-Cloud is there. I had no idea what S-Cloud. Anyone who hasn't seen the presentation have an idea what S-Cloud means?
SoundCloud?
Sorry?
SoundCloud? No idea.
Almost. Well, I mean, actually, completely not. But I typed that in Google, as you do, right? You wanna know, and Google said, "You mean cloud?" And then, no, I mean S-Cloud. Yeah. Now you put it between brackets, and do you really mean it? Yes, I really mean it. And you indeed get SoundCloud. So it turns out it's a and I got that. Let me click on the next slide. Let me talk about this really quickly first. I'm also counting queries, and you see the query volume on the right-hand side. You see that the query volume is all over the place, and that should give you a hint in that the popularity in the amount of hosts compared to the popularity in query volume is not the same. So that's why we calculate things differently. Now I can also order by query volume, and you get a different ranking basically. But from all the top level domains that haven't been allocated or delegated and are not special use, this was measured before ICANN approved .internal to be never, ever delegated. So that's why I'm not calling that special yet here. You can see that S-Cloud is way above internal. And I've already told you that it's really, really hard to go from let's say 50 to 20 because of the log scale. It's really, really hard. So where does it all come from? So after I couldn't find it on Google, I basically looked at the packet capture. And there's an enormous amount of things that say collector.azure.microsoft.scloud. And there are a few others. I say many, but many is debatable. I just say a few other Microsoft.scloud strings observed, but they all the scloud had a second level domain of Microsoft. So I'm going to assume, hopefully safely, that it was Microsoft. And the culprit seems to be Microsoft Team version, released about around April and May 2024. Because next to collector.azure.microsoft.scloud, the other string that often appears is teams.azure.microsoft.scloud. All right. So what is the history of this thing? That's also interesting to measure. And in order to do that, you need to have a baseline, right? I mean, I can just blindly plot a graph that shows you how .scloud was performing, for lack of a better term, in the last couple of months. But it's easier to compare things. So what you see here is .internal. And .internal was pretty stable. You see a few dips. Those are my bias. That's when I was either not told by the DNS engineering team that they were moving traffic around, or my own scripts fell over, which is a little bit more likely. That's why you see a few dips here on the, oh, I can use shadow pointing. There. So that's why you see a few dips there. The top one is the ranking. The middle one is host. So let's forget about the log scale in the top. This is an actual count, and you see that internal is pretty stable. But that's the amount of hosts. Now, I found out yesterday from my good friend Dwayne Wessels, who happens to work at VeriSign, that the drop there in .internal, in the amount of queries that you see, around December of last year, January last year, was because he contacted someone at Google, I don't know who, but also at Amazon Web Services, and Amazon Web Services stopped issuing .internal queries. So the bulk of the queries came from large cloud providers, and it's a good thing. So it looks a little bit counterintuitive though, because finally ICANN approves like a .internal to be never delegated, and everyone can use it, and everyone stops using it. But of course, that's a false truth. So now let's compare this to scloud, and you see this red line. Red line is scloud. You know, red is bad and blue is good. I should have used green, but I'm a little bit colorblind sometimes. You see, remember the log scale above? You see this whopping rise. That's an amazing amount of new hosts. I've plotted that in the middle graph. The query rate is actually pretty low. It doesn't even register on the radar, right? And that's because internal query rate was so high, it dampens the scloud query rate. Now, if I zoom in on that period where you see the bulk traffic, you see this base. This is April and May of this year, and two significant dates stand out. And I think, yeah, that's about 11th of April. I have that here. Yeah, that's 11th of April, and this is May the 16th. So on 11th of April, you see an incredible amount of new hosts coming online, asking for, not coming online, so starting to ask for .collector.azure.microsoft.scloud. And on May the 16th, all of a sudden, the query rate increased. And that ties very nicely to this. This is Microsoft Teams version. This is a mobile iOS version. And the reason I'm listing the mobile iOS version, iOS is the stuff on your iPhone and iPad. And you know this, but there's a reason that iOS is interesting, because iOS is one of these operating systems where you can choose, and I think it's by default, to automatically update whenever there's a new version of the of this mobile app, of the Teams version. I mean, sometimes you can update it yourself, but more often than not, it automatically updates. And you see that on April the 11th, a new version has landed, and also on May 16th. Now, there are 36 variations of Teams. You can imagine you have one for Microsoft Windows, you have one for Mac OS, you have one for Android, you have for all different platforms, and including some government-specific platforms. They're all on this page. I'll list the link in the end. And none of them matches April 11 and April 16, sorry, and May 16, except for this version. And we also assume that the iOS platform is pretty popular on your iPhone, right? So we should see a fair amount of queries when it updates with this new feature called collector.azure.microsoft.xcloud. So we talked to Microsoft. I talked to one person at Microsoft that I've known for a very, very long time. He agreed with me that this was a bit of a bad form, right? Picking xCloud. I mean, everyone knows here that you shouldn't do it. It doesn't mean this never happens. So he reached out internally, and he got it fixed. At least this bug has been fixed. I still think they're using xCloud, but not in a massive amount. We did what was right. We shared everything we had on it, and they confirmed it was a bug and it will be fixed in subsequent releases. And so we can check that actually, because we've done some measurements since then. And you can see it gradually goes down. So it's xCloud compared to Eternal. It is not there where it was before May or before April, but it's slowly going down. The amount of hosts definitely going down, and the query load is also going down. You see all the way on the left where it came from, right? That massive amount. So it's now basically in the 300s, 400s in ranking on DNS magnitude. I have collected all the stuff that I've used here on the slide. So you can, if you can find the IEPG slides later on, you can find these links and you can check stuff for yourself. Now, whom of you have heard of xCloud before last Wednesday? Oh, good. Then I'm not alone. So I was, sometimes when you see these things, you check out with your peers. So I asked people like my good colleague Paul, have you seen this? He said no. And then I asked Dwayne from VeriSign, who looks at his data all the time, and he said he hadn't seen it before. He also reached out, or VeriSign also reached out to Microsoft in their own way, and they also helped fix it. So that's my presentation. Thank you. How am I doing for time?
You've got another 2 minutes to ask the question.
All right.
Thank you. I think this is cool. No questions? Cool. Well, thank you. That was fascinating. Next, we have network observability, which is Thomas and Dan. And who's going first? Where's the slides? That's the Bill's journey.
Yes.
Let's just make sure the clicker still works. Yes, there we go.
Yeah. Good morning, Dan Boyer from Bell Canada. So I'm going to go over a little bit of our journey in network analytics. That's the context of this deck, is about being happy and proud when we have outages, and trying to explain what happened and can we solve outages or get the root cause of an outage faster. I can cite a couple minutes from anywhere across the backbone. So this is our journey. We started about a year ago. What you see there is the mountain Matterhorn. It's just a symbol in Switzerland because of our relationship and collaboration with Swisscom and Bell Canada together. There you go. So we started, like I said, about a year ago. It wasn't as easy as we thought. So the context, again, here is to provide network analytics from across the backbone from every single piece of the network to be aware of the analytics. So in this context, we're using BMP for BGP monitoring. We're using IPFix for traffic, real customer traffic analysis. When we have drops on routers or when we have different traffic spike. We're also using Yang Push. We've been introducing Yang Push or Yang or telemetry with XPath, different XPath for CPUs, utilization, and so on. In this context too, we're monitoring the customer service. We're not monitoring anymore just the box or the node or the router itself, which is a different mind shift in our organization. So in our organization, we're really structured in different network domain, and usually, typically, a domain will have their own tools to monitor their nodes itself. Now, when we have a customer service, it goes across multiple domains. So if you take, for example, wireless mobility, so from cell tower to the RAN, from the RAN to the access, the aggregation, or the metro, the core, all the way to the packet core that usually is in a data center. So that would be multiple domain for a service. Internet is another one. L3VPN for enterprises will be another one. From a NOC perspective, they are the ones that sees it all, but tool by tool or node by node. In here, we're really changing the game here by looking at the service. Another aspect from our road was that there's multiple vendors in our network, and they all evolve at different speed or different levels. So it's not everybody that has the latest of IPFix, for example, or the latest of monitoring for the different XPath. So that is a challenge to introduce those type of telemetry when it's not standardized, and that's why we have the IETF for that, and we're using this to push the vendor in a single direction. There's also the fact that inside an operator, there is a roadmap for when we introduce features where we have to subgrid routers and so on. So that also is part of the challenge. Now, the quality of the telemetry, like I mentioned, depends really on where the vendor, the Cisco, the Nokia, and the Juniper, they are at with the different telemetry systems or feeds that we have. So far, after a year, we are now more than 200 nodes so far. And we're trying to provide analytics in different dimensions. There's better drawings that Thomas is going to come and talk about. The few roadkills were really the attempt of software upgrading some of the nodes and unable to have all the vendors at the same level in terms of features. That is becoming very strategic for the company to help and troubleshoot almost instantaneously when there's an outage. Yeah, so this slide, I'm just gonna go quickly over. That's our agreement, and when we signed this agreement, we accepted to co-develop a few features that we're gonna be using in terms of telemetry streaming. Okay, so this is one of the first outages that we started to look at. This is a BNG. The BNG is really when you are at home and as a subscriber, we authenticate you when you come in our network. And while we were doing a software upgrade, we created an outage because the backup didn't pick up while the prime was getting upgraded. That means we were in a dark spot for about 20 minutes, nothing was happening. So this is just a corner of network. It wasn't like a case where all subscribers were down, but in that particular region, we affected over 30,000 customers. That includes wireless, that includes many different type of customer when this happened. That slide also is part of our ritual at Bell. So at Bell, what we do every morning, 8 o'clock, all the leadership, we gather in a conference call, and we review the outage of the day before. And that is a template of if the outage happened in your domain, then you show up with that template and you fill the blank. And you have to explain a little bit what happened and how long did it take before we detect the outage? How long did we take to fix the outage? How many customers was affected? And what are the next steps? And we go over that since we started to do that since COVID, obviously, because the whole network got overloaded pretty bad, like most of you, I'm pretty sure. The root cause, yes, so that's pretty much it. In this case, we affected the IPTV in a particular area. That's pretty much it. That's that slide. Okay, so that outage coincided with also Swisscom had the same type of outage. Exactly BNG, same vendor, backup did not pick up on time. So the reason of that little picture there is because it's we're drinking from the same cup. So when an operator collaborates with another operator, what happened for one is good for the other one and vice versa. So we're really comparing apple to apple when we do these things. That's the reason of why this collaboration happened. And then together we can push the standard or push the vendor to together to get the latest of the features. So here we're comparing the two different outages, and we also share the postmortems. We up on the calls to review these things together. Okay, so this outage happened in last August. It's not really an outage, it's a weird outage actually. We had about like 6 different links, and over the summer we lost 1 or 2 links at the time. So from a customer perspective, the traffic was coming on the 6 links at the same time, as if it was like a port channel or something. Now, if you lose, say, 3 links, there's only 3 links remaining. That means that half of the bandwidth is available for the customer. Now, we know as an operator, just like any operator, when the outage happened, we know that. We know in minutes or even before a minute, in seconds. What we don't know all the time is the impact. What does that mean for the customer? That is very hard to know. So if there is 1 or 2 link that remains up, customer is still connected, but we're dropping packets and even services such as mobility or wireless or TV, like the huge bandwidth type of services are being dropped drastically. And the customer experience, it's working, but it takes more time to download, upload, and so on. So as a customer, we are in our little bubble thinking, well, it's still connected because there's 1 or 2 or 3 links that remains up. And those links that went down in our process, you just don't know. It's not just a fiber cut. I think one of them was a fiber cut. Another one was the fiber was dirty, so the technician cleaned the fiber but didn't think to put it back up. So it remains down. And then you have a router that just go down because the line card didn't reload properly. So the few links that stays up, as far as we're concerned, the customer is still connected. But again, the user experience is not as it's supposed to be. So those are the things, those are use cases that we think with analytics, the goal would be what is it for the customer, and should we care if we're dropping packets or not from a customer service perspective? That's where we're going with this one. So the main objective of the overall analytics in networking is to be able to detect anomaly detection in near real time. Near real time would be, KPI would be, say, below 7-8 minutes before the customer starts to call us and report a problem. We'd like to be able to know exactly what happened. Even like I think one of the cloud guys, while you're waiting on the call in the queue, we already know where you're coming from and what's going on in your area while you're waiting on the call. And then we can almost reset something to fix your problem before we even pick up the problem. Part of the use case also is to provide a visualization of the network, which is really important for the operation. And we also would like to use the telemetry to keep optimizing the network in terms of traffic engineering. So if we have a few links, sometimes I call them the dark link. Dark link would be the link back-to-back cable that are not used. Those links are there only if there is an outage. So can we use those links to stop putting too much money in the network if the links are not done, are not used? So I call them the sleeping capex. The link is up, but there's no traffic going on. So we have a few of those links there. And the goal would be to use some traffic engineering or steering traffic to be able to use those links anytime it's available. Traffic and troubleshooting, the tracking or prediction. Prediction would be useful for, we know what's going on at certain time in the year. We know there will be traffic spike, and we allocate more bandwidth for those traffic spike, and then pull back the bandwidth if it's not used. And then be more custom in terms of our policy. Policy means routing policies, means controlling better the blast radius of certain network domain. The idea is this is all available as soon as you start collecting a bunch of traffic speed with the protocols I was talking about before, like the IPFix, the BMP. If it's all centralized, the data sits in some kind of a data lake, and then from there you have different type of application that can take advantage of that data that is being centralized. Now, there's a good framework, 9232, for to explain a little bit more, go deeper in this type of these type of use cases. Thank you. So I've talked and covered a few outages. It's some kind of an open kimono for an operator. That's not natural for us. My last slide on my last point here, how about you guys? Do you have any outages that we can talk about? And how do we fix them? How do we innovate?
Hello, Jelinkova. Thank you very much. Very interesting. But I'm just curious about how much details you can share, because in general, yes, it's all great. In my world, the problem is monitoring like explicit signals, like links up and down, is easier. What is interesting to detecting when everything looks normal, but the traffic is not going through. So you need to look for anomalies, and you need to differentiate anomalies from, I don't know, fire alarm and people leaving the office, things like that, right? So I'm curious if you can share any details or any recommendations or your experience with correlating those indirect signals into real outages and how you like detect them.
I think it would be more in the context of the network analytics. So one of the use cases that I've been showing, I would expose the outages that triggers some of the use case by the network analytics that I was talking about. So a fire alarm in the building or a generator that goes down, maybe it could help because you're losing power, and maybe one line card turns off because you don't have enough power. So that could be something useful as well.
Thank you.
Any other question?
Paul Adair, Infoblox. One question is, have you looked at adding DNS data into your discovery?
Yes. It's a good question because maybe my slide was just showing routers and links, services, load balancers, firewalls, DNS, DDoS, all that is subject to be part of the anomaly detection. Yeah.
Great.
Good.
Thank you. And now we have the second part of the slot, which I believe is done.
Perfect. Cool. Thanks. Good morning, everybody. So me and Dan, it's not the first time that we are on the stage and presenting some network incident related things. We started that at NMOP in the interim just like about 2 months ago. And I still remember Rob Wilton came up and said, bring your own incident. So coined that word. So we thought, okay, in that spirit, why not come to IEPG and share our experience in this area? Because we really believe that what we are seeing in our networks, it's not unique. I think other operators experience the same issues. And by sharing that and also how we are dealing with that, which basically monitoring tools we are using that, and also to pick up Jens' questions about how we can share data, labeled data, and then together basically as an industry steadily improve and address these problems. So as Dan mentioned with RFC 9232, there are a lot of IETF documents basically describing which data should be exposed from the network. And at the end, it's not only make the data available to the network engineer, it's also to automate network monitoring. And what Dan mentioned before, what's really important is to make the context towards the connectivity service, because the connectivity service is that what the customer at the end is using, so that we can make the relationship towards the customer and understand if he's calling, basically how he is affected, how he's related to our connectivity service, and we can give him proper feedback when the service is being restored. Now, when we talk about network telemetry, we think about holistic network monitoring or network observability. So that means having the visibility across all 3 network planes and preserve the relationships among those planes, and also the relationship towards the connectivity service. So the connectivity service is the so-called intent. So basically what we want to achieve on the network. And at the end, it's all about correlating the data which we are collecting from the network towards these connectivity services. And importantly, do that in near real time, because it takes about 7 minutes to get the first customer calls and probably another 8 minutes until you are in the media. So that means concretely on the forwarding parts of your packet, basically we are using IPFix, Yank Push, and BMP to export this data from the 3 network planes to real-time correlation among these 3 planes, and also make the association towards the connectivity service. So at the end, that we can map a particular customer flow in the customer data plane down to the provider data plane, and also towards the control plane. So when topology changes are happening in the network, we know exactly how it impacts the forwarding of towards the customer. So whenever we are still forwarding traffic or dropping the traffic, and why we are dropping the traffic. So regarding network anomaly detection, the goal here is basically be faster than the customer. That's not that easy. And also that we bring automation into the network monitoring. So basically remove all the boring tasks from the network engineering teams. So at the end, we are notifying them if something is changing on their connectivity service, and give them the right data so that they can be capable of drilling downs. And also postmortems take a lot of time. So we need to automate the postmortem process as well. So there is steadily a refinement process needed for reducing the amount of false positives from the network anomaly detection system. And even better, even more important is Swisscom doesn't have enough incidents. We need more incidents. And in order to do that, we need to exchange data among the different network operators. So not just by sharing slide decks with each other and describing that to each other, do that efficiently by exchanging labeled data, and then using that labeled data in their own systems and then start the refinement process there. So that's why at NMOP we have these 3 documents in here, one describing the architecture of anomaly detection, another one about the anomaly semantics, and the third one is automating the post-mortem lifecycle process. Now, let's get started. Before I go started, let me ask the audience here. So probably everybody knows more or less about BGP. Do we have any network operators in the room who ever experienced that the BGP peering went down because the max prefix has been reached? And that, of course, unintentionally. Please raise your hand. Okay, so we are not the... So we are not the only one, right? So it seems to be a general problem here. So let's see how we are dealing with that problem, or at least on Swisscom side, and what we are trying to improve here. So usually in these postmortems, we start like with the storyline, like what happened, and then we go over what are the operational metrics we are collecting from the network, and third, basically the analytical metrics, what we are deriving out of these operational metrics, and last but not least, where can we improve? So here in this incident, basically a long time ago, basically on an inter-AS option A peering, so we are in an MPLS VPN environment, SNMP traps were being sent because we are getting close to the limit of the max prefix. However, those SNMP traps are being sent, but not being observed, means nobody pays attention to it. And then, of course, at one point in time, it happens, the limit is reached, and it doesn't reach just one single peer, because if you have redundancy, usually you have the same peers multiple times. And of course, on all those peers, at the very same time, you're reaching that limit. So all of those peers goes down. And what happened next is basically the connectivity service. So the VPN, which is basically peering over those inter-AS option peer, is now affected. So that endpoint is no longer being reachable. Then the next thing is happen. It's not basically now the team who's getting monitors the network notices that those peerings going down and start the investigation, reaching out to the platform team and saying, hey, the peers went down, can you please investigate? And now a peering has usually 2 sides. So and then basically both parties on both sides trying to figure out what really happened in the network, and then finally understand what happened, raising the prefix limit and reestablishing that peering. And you see, like, from the time when the peering goes down to the time when basically the problem is being fixed, it took us 40 minutes. Not that bad, but we've been warned that that peering is going down for several months. What you see on the picture here is basically the BGP data which we collected from the network through BMP route monitoring. You see the updates and withdrawals. You see that for a particular VPN who is connected to those inter-AS option A peerings, and from where basically, from which next hop those updates and withdrawals has been advertised from. Now, I have 2 basically statements in this slide here. On the right-hand side, we need to change. So change, innovation, transformation means usually you're going through different stages. So you have an idea that's envisioned. It's operational, you prove it works. Applied means some of the people are actually doing that. And then basically it's accepted. A larger group of people are actually using that. And it goes then up to vital. So if you turn it off, everybody is screaming. To basically, it's getting towards naturalized. Basically, you don't even remember anymore that somebody has invented it. And by moving from classical device monitoring towards network monitoring, so you're monitoring end to end and you don't care anymore basically what's happening so much about each and individual devices. You care much more how the network is connected with each other. And you're bringing away your network engineer from show commands on the devices because, hey, you cannot log in on hundreds of devices at the same time and do so many show commands just to figure out what's happening end to end on your network. You bring them away from those show commands towards doing SQL commands in a database. So at the end, they're monitoring the network holistically and understand what those changes in the network, how they impact with each other. This transformation in a company takes time. And we are depending on if it's about the data collection, if it's about anomaly detection, we are in those stages within Swisscom. However, those transformation we also need to do in the industry. And on the left-hand side, I showed a little bit what it means on the network telemetry protocols. So we are, since a few years, involved on bringing segment routing into IPFix, but also to cover with BMP all the different RIPs, and from the RIPs also how BGP best pass decisions, and also basically how events in BGP, so when a policy denies prefix, that we can make these things visible. And last but not least, and Dan has already mentioned it, Yang push to get Yang matrix out of the network is a pain for network operators today. So basically onboarding those devices in our data mesh or in our big data infrastructure takes a lot of manual effort and takes days or weeks of effort, and we want to automate and simplify that thing. Now, these are the operational metrics we collected from the network, and we can see basically on these pictures different views. Some of the views are related to the control plane, other views are related to the forwarding plane. So on the left on top, we are comparing the traffic to the previous week. This is important basically if the dropping device is outside of the monitored domain. While on the right-hand side on the top, we are looking at basically how many flows, so how many transport sessions are going over those VPNs. That's important, especially if you have congestion in your network and basically retransmits are happening. So if you have a spike there, usually means there is some convergence issue in your network. And then at the top on the left-hand side, we see BMP peering state changes. Obviously, peerings went up and down. And then we have traffic drops. So basically, the networking device is the one reporting to you. We are no longer forwarding traffic. And in this case, because there was no next hop available in here. And just these SOS marks usually show we have a problem in here. In this case, it was a vendor bug. Basically, BMP has a nice feature. When the BMP peering goes down, basically the notifications are being mirrored. So basically the notification tells us why the peering is going down. Quite an important message in this case. And the vendor was just not mirroring that information. So these are the analytical metrics. So this is not what we are collecting from the network. This is basically how anomaly detection derived that information. So we have various checks in here. So whenever the topology is changing, whenever the peerings are changing, interfaces are changing, whenever we are missing traffic, whenever we are having drop spikes or flow count spikes in the network. And we are observing that, and we are consolidating that into one concern score. So the more the concern score go up, the more likely our network engineers should look at it, because we might impacting the customer service. Now, let's talk about what we can improve. And this time, since it is BGP related, it's the GROW working group. So we have a fantastic document about bringing route events into BMP. However, before revision 02, it is mainly focused on the route policies. So we said, we need something more there, the maximum prefix threshold. So when basically we are dropping prefixes, so when the peering not would go down, we want to understand which basically passes are being dropped and why they are being dropped. So because of the maximum prefix configuration. Then BMP has also statistics on peer. Here we would like to have a counter telling us how many passes are left until we are reaching the limit. That could be then very easily be monitored. And that's the main two things which we addressed at GROW, and now it's included in the documents, and hopefully now we are getting soon vendor implementation and we are one step more closer. That's it. I hope it was interesting.
We have a question from Linda.
Sure. Hey, Linda.
Linda Dammer from FutureWay. So it's very interesting. You listed a few drafts, and I remember IDR also have a draft about this prefix exceeding, and that draft kind of went expired. And so I'm just asking the audience, like, what if just ignore this prefix exceeding, just let the BGP session still run? Would that be a problem?
Right. So to be very honest, that you act as a normally the reason why you configure a max prefix limit is because you want to protect your BGP process. But the problem is like you have one routing table, like one local RIP, for instance, and you want to prevent that this local RIP is somehow overloaded. However, if you have many different peers, how much do you allow on which peer so that a local RIP is not overloaded is not a trivial task.
Okay.
And I think maybe that could be simplified somewhat. And what we show here is basically, it's not only about simplifying or making the configuration easier, it's also about monitoring it constantly in a proper way.
Thank you. I didn't get a chance to read those two drafts. I'm just curious, like, can you allow simple strategy, just let the older one be expired, like if you haven't received for a while, and then let the new one come in? Would that be a problem?
There are already such mechanism you can configure, like not taking the peer down, just basically denying the most recent one.
Mhm.
Those two comments mostly focus on getting the proper statistics from the peering so that you know how much you have left. And then if you start denying, that you're understanding which passes are you denying.
Okay, thank you very much.
Sure.
Sure.
Alexander Azimov, younger. So I have a feeling that I will partially repeat what Jen was asking, but so it's easily to justify why you need network monitoring, because especially if you have no and now you have something and it is increasing, you have increasing number of signals, BMP, IPFix, data plane monitoring tools, black box, white box, whatever. But at some point of time, your duty engineers might be overwhelmed by the number of signals. And on this slide is anomaly detection rules. Oh, no, just the last one. Yeah.
Mm-hmm.
It was just on the.
Yeah.
So there is some correlation mechanism or rules. So it's very interesting to learn how you are building the hierarchy of different rules that helps duty engineers understand of the root cause of the problem.
You're raising a very good point. This is my last slide. So if you want to know more about incidents, maybe I want to look at SRv6. There is a session in SRv6 op. And if you want to know exactly more about how those rules are being defined, what's the architecture, what are the semantics and everything, that's in NMOP, those three documents I was explaining at the beginning. There are also some papers behind. So yeah.
Okay, thank you.
And maybe one point on the monitoring. Usually monitoring is something very boring because if you don't have incidents, nobody cares. But if you have incidents, then suddenly things getting a bit exciting.
Okay, thanks.
Great. Thank you. Go. You're not in the queue. Go fast. Fast like a bunny.
Jelinkova, just comment. I think we need to differentiate here between monitoring and alerting. The data you collect from the network, you probably must not show all of it to your operations team, right? They only need to see this much and the rest of it is for troubleshooting and digging and so on. So I just wanted to make sure we're not confusing those two.
Right. So in the beginning, I was showing this slide. So there are different main use cases. So we call verify, troubleshoot, and notify. This is like the workbench. So make the metrics easily available to the network engineer, while anomaly detection is just one mechanism to automate the network monitoring, because you cannot ask engineering teams to always query and look at the data.
Great. Thank you very much. And now we will put Philip Helen Baker next, because we're trying to put Andrew Complin at the end because Paul Vixie would like to show up. So I'm going to reorder these if I can find the slides.
I uploaded
Yep.
them.
Hopefully these are the correct version. Is there only one version?
Yeah.
Then it's
Yeah.
correct.
Okay, this is something that I kind of like came along and I kind of like implementing a website and doing a file upload. And I kind of like suddenly realized that, yeah, some fool had screwed up 30 years ago. And that was me. So, it's very simple. All I'm trying to do is to just upload a file to a website. And it suddenly struck me that we've been doing HTTP wrong. So if we go to the next slide. So the problem here is when you upload that file, HTTP forces you into a request response paradigm. So you have a file, here's a file, post it to the website accepts all the data and then says success, which sounds like it's what you want to do. But what if that file upload, instead of it being a small file, originally when we were writing the post method, it was for, I was posting mails, short mails of, a few lines. What if you're uploading a file of a megabyte or whatever, and the link isn't really that fast? What if after you've uploaded it, you're then going to do some processing on it? Because, my program's doing some parsing or whatever. Aren't you going to want to give the user some feedback along the stages of the journey? And so what we've conflated into this subordination paradigm of request response is actually much more naturally a post followed by an initial response, hey, I've got the data, followed by processing, followed by I succeeded with that processing successfully. And when you're trying to map this onto web services generally, that is actually far more commonly what your procedure looks like. If you're connecting up to a temperature gauge, you want to say, tell me the temperature in the room and tell it me at 5 minutes intervals. And, HTTP forces you into this request response thing. Now, that wouldn't be a problem. Only the thing is, if we go to the next slide, we kind of like got into this thing somehow where all protocols go over HTTP. And again, I'm kind of like one of the guilty parties here. And, we do everything over web services, and HTTP is now designed as a web service protocol. It's designed to do web browsing. It's designed, and if you look at most of the code in HTTP, when we were talking about HTTP 1.0, which was when we got into this mess, a web service was using maybe 20% of HTTP. Now, HTTP has grown. It's a large stack. And you're using this minute amount in a web service. And the first thing you do is to turn off caching. Well, that's about half of HTTP to starters. And then you turn off this, you're not using content negotiation, you're not using this, you're not using that. All you're really using is the ability to map multiple services onto one TCP port, and framing so that you can have messages that are variable length, and getting through the firewall. And so I'm kind of like looking at this and, yeah, what I really want to have is application security, MAC per message, and flexible message patterns. And as I'm looking at this, well, that's exactly what the folk doing media over Quick have come up with. And the thing is that, yes, people have been noticing that HTTP is not optimal for web services for quite a long time, but we've not been in a situation where we could do anything about it. If you go to the next slide, this is, so yeah, now we are in a situation where we can do something about it. We're moving to Quick, and Quick means that you're getting through the firewall. And how about we look at doing this intelligently and doing this in a principled manner? I think it's probably going to happen anyway, because other groups are going to look at, face the same problems that Mock have faced, and probably borrow tropes from Mock. And so we're probably organically going to grow into a web services 2.0 world. But maybe if we actually make this into a conscious movement instead of unconscious and organic, we might do it a bit faster and a bit better. That's all. Comments?
Great. Thank you very much. Let me see who we have next. I guess if Randy's okay, we will have Randy next. Do you want to present? Would you like me to present? And you just say next, whichever you'd prefer.
I'd like to do the clicker if you don't mind.
Okay, give me a second to. There we go. Take it away.
I'm not seeing the clicker control.
Oh, I think that you have to request presenting then if you want the clicker control. Otherwise, you can just tell me to.
Okay, I'll do that. Principal instigator of this is Oliver, by the way. Next.
Sorry, it's not
Okay,
changing.
there are two
Sorry, let me just restart. Perfect.
Okay. There are two drafts here. One is on prefix lengths. The other is on, oh my God, we're creating these things. Let's consolidate to generalize external references next. So the initial motivation is that applications want to know the width of the IP space being used by a single customer. For instance, if I'm blacklisting something for spam or DOS or something, I don't want collateral damage in an adjacent part of the IP space. So I want to know whether the provider is giving out 24s or giving out 20s, et cetera, et cetera. Also, you may not notice that the number of captchas you're seeing is going down. And that's because they're getting smart about it. And if they know you are behind a certain address, they're not asking again. And they cache this at the CDNs and at the core servers. So they also don't want to have collateral benefit as opposed to damage by thinking you're in an adjacent space. So next slide, please. We want to publish what the prefix length is the provider is allocating in a particular address. So for instance, here we are in 2001 Dogbaker 8. It's a 32, but the provider is slicing it into 56s to hand out to the customers. And similarly for IPv4. So it's the width of the allocation within the prefix. Next, please. Use the same hack as we used in Geoloc. Okay, so you're in the who is in the internet routing registries at the RIRs. There's an initnum object, and you have a prefix length attribute that points to a file that looks like that previous example. In the interim, before the, just like geoloc, pardon me, not geoloc, geofeed, just like geofeed was originally, you just put it in a remark until the RIRs implemented it as a first-class attribute. Next slide, please. There's an interesting case of CGNATs, which is that, of course, I, as for instance, the CAPTCHA provider, puts up the CAPTCHA. I don't know that /24, there could be 100 users behind it. So the CGNAT will please say how much their slicing granularity is. For instance, this example says I'm in 192/20, but I'm slicing down to a /36. In other words, I'm multiplexing 16 customers on each 32, on each IP address. Next slide, please. So now we've got geofeed and prefix len. Oh, goody. There's going to be more because we've started a trend. So what do? Next slide, please. We try to generalize it and we say, hey, there are external references. And we say what the external reference subtype is, and then refer to the object. And the draft proposes an actual IANA registry for subtypes. And because they can get messy and can be security threats, because you don't know what you're fetching, right? These are simple files with prefix data. It could be code. You don't know what an external reference type will be. So we want to control that. So the registry requires RFCs. Next slide, please. Note that the registries, the RIRs, are trying to move from whois to RDAP. As Philip Baker just said, Webbies are taking over the world. The RIRs already have geofeed in the test. This will be a long transition. We need to be aware of it. But it's not going to be magic this week. Next slide, please. But this is kind of what it looks like for these two examples, which are geofeed and prefix len. And I don't know that this is a significant improvement over whois and how long it will take to be adopted, and how I feel about whether I'm going to get what I need out of whois, we'll see. Next slide, please. It's been suggested that there are other attributes that are interesting, not just the prefix length or the geographic location. The kind of customer is it? Is the last mile properties and the published extensible data? Is it 3G or 4G or 5G or 6G or these smell like infinite rat holes to me. To what end are we doing this? If you can come up with a really short list with rigorous definitions, I'll take it seriously. But there's a sad history. I'm kind of allergic to these loosely defined things that are a snapshot in time that could be obsolete. Right now, if 3G dominates, 5G, 6G, there'll be 8G. And once upon a time, I wanted to have a simple marking on the connection to the route collectors, risks and route views to please tell me which of 3 different flavors of were you giving me a full routing table, your internals, customers only, or also your internal, slash 42s. My partner expanded it to 1,000 attributes, and I dropped off. Next slide, please. And the Arts RFC 4384, no one uses it. No one considered it seriously, etc. So I'm kind of allergic to it. So if you can do a really tight fixed set of other attributes to tack on here, I'm not, going to die on this hill, but let's try to keep life simple and direct. And that's all I've got.
Great. Thank you. Jen is in the queue.
Hi, Jen.
Hi, Randy. First of all, yeah, I do agree that the more fields you're adding, the more chances those fields will be outdated and completely unusable because we cannot trust them, right? So it's a human nature. I have a clarifying question about prefix length. It looks like you're assuming that from the given aggregate, there is always the same prefix length allocated to a customer or subnetwork.
No, because you can have a list. You can
Okay.
slice it and dice it, just like you slice and dice in GeoFeed. So I gave the registry, the RIR, gave you 16, but you can publish a stack of 19s in the file.
Yeah, I see. So
Right?
basically, yeah. So I need to, for the given 90s, I always need to allocate the same prefix length, right?
For
Within
that
Yeah.
19, but you could slash it into 220s if you wanted.
Yeah, okay. What I'm thinking about, wouldn't it be it easier if somehow to have a service which would, for given address, tells you which aggregate it belongs to?
I don't think you want to have that query rate.
Okay, fair enough. Because I'm just thinking that might be in human nature, say, oh, for V6, it's always /64 just to be on the safe side, right? So I don't need to worry about neighboring customers being affected. So I can always tell you, I'm always allocating /64s to customers, right? Not 56, not 48, right? Always
Yeah.
/64.
Yeah.
Okay, yeah, thank you.
Hi, Tail. So I like it. Please pursue it.
Weird.
Getting echoes.
On Randy's side.
Okay. And so the question I have is actually ancillary, and I hope not too far down the path of existentialism, but there was an early slide about the motivation that, fewer captchas. So the one thing I'm sure I'm missing a piece of it, but how does knowing my allocation prove I'm not a robot?
No. Okay. So you connect and ask for a service. You're connecting from a particular address. It's the first time I've seen you. I show you the captcha. You successfully identified the fire hydrants and trained my AI for me. I stash and cache your address and your identity. So if you ask again, saying that identity from that address, I don't show you the captcha. But how do I know it's the same address?
Or how do you know it's the same user, not a shell script?
Oh, because they've got whatever it is, they've issued a password or whatever they've come to the website with. But that technology is deployed. They're doing this today. That's why I see less captures, or maybe it's because I'm shopping less.
Okay, thank you.
Eric Nygren, thanks for pulling this together. I think this is useful. And actually, answer to Tail's question, example for this is the cases where you have IP reputation systems, and that reputation system wants to know what granularity to put that reputation on. Like there's a use case from a cloud provider is cloud provider that has 128 plus 128 to users in some portions of the space, plus 64s to users in another portion. Needing to know that is like it would be needed for the reputation system to have the granularity. But for things that I think the extensibility question is an interesting one. Like having some extensibility in this would be nice to have, just because you don't want to keep having more and more feeds, because each type of feed has things. I'm not sure what the right answer is, but I share that same concern about something that's getting stale. The having like a set of flags that are like Boolean flags might be one way to do it. So, for example, being able to say this is a VPN, this space contains VPNs, this space contains CGNATs and VPNs. There might be something in that space that's useful. And to answer Jen's question, it might be worth thinking about. There's got possibly a third track in addition to this. Is there a better way for aggregators who want to collect all of these feeds from various places to get the list of all the geo feeds as well as prefix length feeds, so they can convert them into services you can issue calls against without having to go straight which some of the registries may not be a fan of.
Massimo, who did the aggregator for GeoFeed, is doing an aggregator for prefix len. So you'll be able to slurp it up in one big slurp. But this is going to be in ops area working group. And so discussing more other attributes and what we can do about that, please come there. Next.
Hi, Randy. Sam Weiler. Going again back to the motivation, how do you deal with the miscreants who tell you they're slicing their address space more finely than they actually are to stop you from applying filters to all of it?
I don't think you can do that.
Then why are we doing this?
Well,
The fact that there might be a bad guy doesn't mean there aren't 100 good guys.
Mm-hmm.
Hi, Randy. Peter Koch.
Hi, Peter.
I'm wondering, when we add attributes of the use of the object to the registry database, how that will affect the responsibilities and also the perception of accuracy and correctness. And now you're going to instantly know where this is going to lead, right? Our friends from law enforcement would very much appreciate an external reference to a document that actually provides them with the name and legal address of the subscriber, for example. So that doesn't stop you from the particular things that you proposed, but I do think defining a general external reference mechanism should only be done if we can separate the responsibilities very carefully. Thank you.
Go check out that draft, and you'll see that it's specific. It's definitely worried about that, and I'll gladly take more words if you care to donate them.
Oh, hey, I think I'm next in the queue. Warren Kumari, Google. Actually got in to respond to Sam. Yes, bad folk can do this, but if I'm, for example, a Comcast customer and I've got, a /24 from them or something, Comcast could be like any badness from this blacklist, a 24. I don't have control, but yeah, I mean, some set of people will use it for bad. And we have a Richard.
Hey, Randy, Richard Patterson. I see the benefit and some of the reasons why there is a requirement for a standardization across the regions, but just a bit of an anecdote. So for those in the RIPE region, and admittedly this is solved for V6 only, not V4, there's an aggregated by LIR status, which we can choose, which requires the assignment size as an attribute. So for V6 in the RIPE region, it's already solved. Yeah, statement rather than a question.
Hi, Phil Baker. Yeah, I like this. Listening to some of the comments, I think that some folk are kind of like looking at this in a bit too much of a binary go, no-go state. Right? Basically, the way to look at this is a way of giving hints to interpret the data that you're getting from the network and input that to your abuse AI. Yeah, actually, this is one of those applications where you actually do AI that is AI and useful, but we don't call it AI because we've been doing it for years. But, you know, it's going to be going into some other system that's taking in a lot of inputs and coming out with a thing of, yes, this is spammy, this isn't spammy, this might be, we'll throw up the capture. And so, you know, it's not a go, no-go decision. It's a way of interpreting the data that you've already got more intelligently.
Yeah. And along that line, whether it's 3G, 4G, or 9G, is, you know, the video provider wants that hint. So what bandwidth do they, what resolution do they start their feed with? The fact is, any video provider with sense is going to immediately adjust, just as they do now. This is just a hint, as Philip says.
Thank you very much. I think
Ciao, it's been fun.
Thank you, sir. Just removing Sam and Eric from the queue. And I think next up, we have Andrew Kemplin and Paul Vixie on encrypted ECH and operators. And I'm not sure if both are presenting or who's doing the talking.
Andrew's doing the talking.
Great. Let's just make sure this works. There we go. You can drive.
Perfect. Thank you. Morning, everyone. As the slide says, I'm going to be talking about encrypted client hello. That's for those of you that don't follow the TLS working group intently. Shame on you. That's a proposed extension to TLS 1.3, which is currently in development. I'll explain the status in a moment. I'm mainly going to focus on the relevance implications of ECH for network operators. So this is based on conversations with a range of network operators. Depending on your individual worldview, some of the things I'm going to call out are features or bugs. Both points of view are valid. Just to perhaps save a conversation about that later on. I'm pulling out some things which are covered in more depth in an internet draft that a number of us, I've spelled Paul's name wrong, that's pretty bad as he's in the room. Paul Vixie, David Wright, Arno Tadai, and the late Simon Edwards are co-authors on the draft with contributions from a bunch of other people as well. So I'm going to talk a little bit about the background to ECH, give you a view on the current status, but mainly focus on some of those implications of it. A little bit of background. The plain text server name indication extension in the client hello has been sort of highlighted as perhaps the most sensitive unencrypted information in TLS 1.3. So I guess for the people in the TLS working group, that was a bit of work to be done. And because of that, there's, as I said, a new extension to TLS 1.3 currently under development. Originally, it was called encrypted SNI, not very imaginative, but I guess a functional description of it. But recently been renamed encrypted client hello, but it encompasses encryption of SNI plus potentially some other things as well. And as an untechnical explanation of what it's about, basically, when you've got a bunch of people accessing, say, a CDN, and then a load of different services behind the CDN, as I'm sure you're all aware, you need the SNI data to work out which particular service is being accessed. There was RFC 8744 took a look at the usage of SNI to try and understand whether there will be any negative unintended consequences were it to be encrypted. Rather interestingly, it had it coined the phrase of unanticipated usages of SNI. I think, in my view, shamelessly ignoring the concept of permissionless innovation, but there you are. And within RFC 8744, there was a brief, literally 2-paragraph assessment of the alternative options that could be employed instead of the quotes unanticipated usages of the SNI data. And it asserted in that document that most, as I didn't try and say which ones, of those unanticipated usages could be realized by unspecified other means. It didn't state within the document what those means might be or how practical, affordable, or realistic that they may be, but nevertheless asserted that they were available. As you might imagine or might detect, I'm not a fan of that document. It felt somewhat lacking in its analysis, in my view. But nevertheless, the work has proceeded to encrypt the SNI. There has been some quite extensive interoperability testing. You can read the current version of the ECH draft on the data tracker. It's currently up to draft 22, so it's gone through a number of evolutions. My best guess, it should come out the other end of the IETF's standard sausage machine roughly sort of by the end of the first half of next year. Could be early in the first half, depends on the speed of the IESG. And obviously what this is about is to try and stop unauthorized observers from seeing the stuff that I want to access. There are, in my view, unintended, or dare I say, unanticipated consequences of stopping that observation. Again, as I said earlier, these could be features or bugs depending on your perspective. But yeah, for example, it can adversely impact things like content filtering, firewalls. Some of us might think it's quite important, cybersecurity, compliance requirements, some of which are legal compliance requirements, etc. So there's a whole bunch of implications, which, as I say, some of you may view as features. Looking at those, just to consider some of the implications, if you run a enterprise network in certain regulated sectors, and the number of regulated sectors is expanding quite quickly, you may have compliance requirements. You may, for example, if you're in the finance sector, you have an absolute requirement to have 100% audit trail of all inbound and outbound communications if you're in the wholesale finance sector. And some firms were fined by the US regulators a couple of years ago now, $200 million each, because they couldn't furnish that 100% audit trail. And it wasn't their fault. It was because of some unknown activities by some of the users on their enterprise networks. So as I say, that cost each of those companies $200 million, which is quite a chunky fine for potentially a first offense. It also means if you can't see the SNI, you're not going to want to implement bring your own device, because a lot of BYOD implementations use the SNI data to implement transparent proxies. If there's a risk the proxy will be encrypted on your third-party device, you will be mad to allow that onto your enterprise network. So that if you're talking to CISOs, I think you'll find as they become aware of this, they won't want to see bring your own device on their networks. I won't go through all of these. I'm going to move on to the network, public network operators in a second. I'll also just highlight though in schools, in the UK and the US, for example, schools have to operate content filtering. It's not a choice, it's a legal requirement. Certainly in the UK, it's a legal requirement. In the US, I think it's a requirement if you want to have access to certain federal funding. You have to have content filtering. You can move on to enterprise grade content filtering solutions in a school, but the problem is most schools don't have the IT capabilities or indeed the funding to be able to do that. Your typical IT manager, certainly in a UK school, is the person that changes the bulbs on the interactive whiteboards, resets passwords, and as a sort of a 5 minutes every other weekend runs the network as well. So expecting them to act as a sort of net admin with sort of enterprise tools is almost inevitably going to be unrealistic and beyond their capabilities. And that's not to be sort of to denigrate them. It's just, yeah, that's a level of expertise that they typically have. Now, if we look at public network operators, and as I say, this input is from a range of network operators. It won't be universally true, but it gives you an understanding of where the visibility of SNI becomes important. In some networks, they'll use the SNI for traffic management and certainly traffic steering, particularly the interface between fixed and mobile networks. Also traffic optimization and incident management, just picking up on the topic that was covered here earlier. So it's one of the more useful sort of tools for that. A specific example where SNI is used is for zero rating of content. That's relevant, say, on a mobile network or indeed a fixed network if you've got data caps, which often of the sort of less well-off users will have data caps. They may think they're accessing zero-rated traffic, but if they're using ECH, then that traffic will be metered. So they may find they bust their data cap without realizing, because they've been told by the operator it's zero-rated traffic, but because of their implementation, it turns out not to be. Also, some tools like parental controls in some cases use SNI as indeed do cybersecurity tools for consumers. So again, they may stop working correctly or 100% of the time if the SNI is encrypted. That's also true, by the way, for enterprise tools, where a lot of network operators provide such tools for their enterprise customers on a managed basis as well. And then for fun, public network operators in some jurisdictions have legal requirements with law enforcement agencies and may find that encrypted SNI bypasses the tools that they use. Again, you may think that's a feature rather than a bug, but if you're running that public network and get hit by a fine because of that, you may be somewhat less impressed with that. So, I mean, the advice certainly that I've been giving to people is with ECH, if you run a network, you really need to do an audit of your network, of your various offerings to understand where the loss of visibility of the SNI data may have an impact. You definitely need to speak to your vendors to find out what their knowledge levels of SNI and ECH is. And I think you'll find in many cases it's quite variable. Some have good knowledge, others not so much. And for example, if you're in Europe, in the EU, with the advent of the sort of NIS2 regulations, you have an absolute requirement to do that vendor audit. Otherwise, you may find that you've got some compliance issues with NIS2, for example. And if you're faced with expectations from a regulatory basis that you feel you can no longer fulfill, then if I were you, I would speak very quickly to the relevant regulators and legislators to make a case for some changes in those rules or for some relief before you're hit with a fine for something you can't control. I mentioned there's a draft that we're working on. There's a link to the draft there, which we're planning to work through the independent submissions route for that draft. We were hoping to do it through the OPSEC route, but with sadly, with the demise of OPSEC, the ISE route seems the most appropriate one for us. As a general point, you're here, so this is not so relevant, but I think we need more people with operational experience active within the IETF community so that those operational impacts are better understood by the standards community, so we have less risk of unintended consequences. In terms of where the main ECH draft is at the moment, it's completed the working group last call. It's currently being reviewed by the area director, and the authors are still completing their response to the area director review, and then it will be submitted to the rest of the ISG to go through that last step of the standards process. So it's currently with Paul and the authors to respond to Paul's review queries. It's already in implementation, so if you weren't aware, it's implemented in Chrome, in Firefox, most recently in the Tor browser, and also Boring SSL on the client side. You can disable it, I believe still, in Chrome on managed devices on enterprise networks only. The way that was phrased by Google, this was in response to a discussion we had at the meeting in Vienna a couple of, well, 2.5 years ago now, is that was a temporary change. So as far as I know, that could be removed, but currently it is user configurable exclusively on enterprise devices. On the server side, Cloudflare has implemented support for ECH on, I believe, all of its free tiers, and it's not, I believe, user configurable. If that's wrong, someone from Cloudflare can shout. It is, I believe, configurable though on the paid for tiers through the, I think either the API or the dashboard, if you're a Cloudflare paid for user. I think, yeah, that's it slide-wise. If you have general interest in DNS-related stuff, we do have a call every Monday at 4 p.m. UK time, sponsored by DNSOARC. So feel free to speak to me about that separately if that's of interest. I don't know if Paul wanted to, no, Paul's shaking his head. So questions, comments, thoughts welcome.
No questions.
Sure, I'll take the bait. I'm Chris. I work for Google. That doesn't matter here, though. A bunch of the, I said this in the chat room too, a bunch of the arguments against, or the discussion against ECH to me sounds like, oh, I won't be able to do the thing I always do with the tool I always use. But much of the data is discoverable elsewhere in the network or systems. So I kind of think people want to stand behind their like, well, my firewall can't do the inspection and therefore like we can't do this thing. Well, it doesn't need to do the inspection. You could do this somewhere else, right? There are other signals you could use. I think your point about the UK schools IT administrator is the same my school system has at home. You're right. It's like, it's somebody who doesn't understand the protocol systems and networks to any real degree. It's like you said, it's not a knock against that person. It's just that system we live in. But without the tooling exposed in a better way, it really becomes like, well, my firewall can't do this thing, so we can't move forward.
So let me pick out two separate things from that, if I can, Chris. On the firewall point, I think occasionally, if I may say so, I think in this community, we often conflate security with encryption. And in my view, they're two entirely separate things, which occasionally collide, but they're separate. So in my view, and certainly talking to a lot of the cyber security as opposed to cryptography specialists, the loss of any indicator of compromise is bad. SNI is quite a useful indicator of compromise, so losing visibility of it or having that loss is a bad thing, just in principle.
Sure.
So yes, there are other indicators of compromise.
Yeah, your DNS server tells you this, NetFlow tells you this, activity on the network tells you this. There's a bunch of ways to know that thing is compromised without having to look at SNI.
Possibly, but some of the community are on a mission to encrypt all of those things. Again, that's because they...
You can't encrypt NetFlow, thank you.
Oh,
Good luck.
That's just source destination. CDN. So,
That and behavior analysis,
some behavior.
right? Hi, my workstation here never, ever, ever should make a direct MX query to the DNS server, or it should never make a bunch of other queries. Looking at the behavior of my device on the network over time, like, oh, look, that is a thing doing something it shouldn't do. Let's go talk to Chris. Right.
Yeah. I think the issue is if you're in a big enterprise network that's heavily sort of managed, that's a valid point of view. For your typical consumer user, good luck with that. I think that's what perhaps we're missing in this community, that we're throwing the 95% of the users of the internet to the wolves because of our worldview of largely our enterprise and our very highly expert user base.
Since Chris took the bait, so will I. There's a draft. If there are workarounds to the problems that have been enumerated, I encourage you to join that discussion, because at the moment there's a cost threshold and a benefit threshold that are inverted, and it's gone pear-shaped. The networks who have to do this kind of protection for whatever reason, regulatory policy, et cetera, don't have options which they can afford. And to your DNS example, I'll simply say that if somebody is using DOH, it will not be possible to see that MX record or to have characterized prior traffic. So again, to the extent that there are workarounds that you can help illuminate for the community, we would appreciate you joining the drafting party. I think we should move on.
Paul Adair, Infoblox. I just want to add and point out one thing here, right? Is you'd like this RFC to to be used, not just adopted. And I would point out, in addition to some of the things Andrew said, that Fortinet already in their next gen firewall has options to block this function. And so that's something you should consider is what are how are the the enterprises out there that are going to be passing all this traffic and using these services that are, TLS is protecting, are they going to accept this standard as it is?
Eric Nygren, I think for the enterprise case, that's a little more with managed devices, it's a little more straightforward because there are ways on both the DNS side as well as ECH and others, I think, for being able to set policies to disable some of these features. I think the case of schools is one where there's not a clear answer for, because we are removing the knobs intentionally because it's hard. You can't distinguish between a bring your own device at a school and a bring your own device and some user on their home mobile network, where we are trying to improve the privacy profile. And I do personally worry that without a guidance of what people are going to do, the step is going to start being, hey, if you're at your school, here's your man-in-the-middle CA you must install onto your device if you want to use the school network. And I think that's going to be where some of these vendors will start ending up, which is going to be a much worse state for overall privacy if we don't have some guidance on what people should be doing instead.
Yeah, I think that's a fair point. If, for example, transparent proxies don't work, then I think Eric's point's well made that it would need much more intrusive software on devices instead. So you would take a backward step on privacy potentially.
Janiko, someone who runs enterprise network. I actually would like to quote Randy. He said a few years ago in the similar discussion that law enforcement made too easy called police state. So we kind of have a problem here because in enterprise networks, I agree, right? When I'm on enterprise networks, I kind of understand that all my devices are controlled by enterprise, right? And users know that. The problem with doing this for a random unmanaged device is the problem we cannot differentiate between a good guy and a bad guy, right? So I think we need to be very careful with saying that, yeah, we're going to sacrifice everyone's privacy for protecting children. I know it's a very convenient argument, using children's and schools and so on, but I think we need to be very careful about what we allow random observers to see in general case. Yeah. So, and yeah, I know regulators want to see everything. And I do live in country when prime minister is famous for saying that laws of mathematics are great, but the only law which applies in Australia is Australian law. But I hope we can like work with regulators on explaining that you can only report things which are reportable and only observe things which are observable, right? And no more than that.
Phil Humbaker. Yeah, I'm kind of puzzled by this idea of, yes, we want the schools to be able to see what their pupils are browsing, but we don't want this to be intrusive. I mean, like, you know, if you want to have a browser that tells somebody else what somebody's browsing, then you want to have a browser that tells the user that they're doing that. You know, the banks can use it. I don't see that that is a problem. Having a separate set of browsers that tell people that there is something intrusive happening. That is the desired state. That is not more intrusive, that is less intrusive. Now, as to SNI and so on, you know, I've got limited interest in that. I mean, like, I'm running Quick over Quick. My implementation of Quick runs Quick inside Quick, taking the first 64 bytes and just prefixing everything with garbage so that it'll get through firewalls and so on and make them feel happy. I run my encrypt, you know, I start my, I'm not that interested in SNI. I put keys into the DNS so that I can encrypt the original hello to the host. I encrypt every single bit of every single message backwards and forwards, except for the initial, I'd like to start a conversation. And I don't say with who. I'm going to be going further and further with hard-boiled crypto. And I'm going to be making it in such a way that you are going to have absolutely no chance of intercepting it unless the user uses a device that consents. And the reason for that is I'm really not that interested in your schools in developed countries. My interest has always been the countries where they have a police state, where the government has their boot on the face of the population, places like Saudi Arabia, places like Russia, places like Iran. And that's what I've been designing stuff for. I don't bring that stuff here very often because you know what? It's one war, one weapon. You know, once you let the game away, it's done. But you're just not going to be able to do it. And the other thing, even in US schools, okay, yes, the school is providing the Wi-Fi network. But you know what else? My kids have got these. These have got 5G on them. And if they can't get Facebook on the school network, they just go to their phone. So, you know, I've got very limited sympathy for these issues. Sorry.
So I guess that's proof that this community is not the problem. in that sense, because if you like, that knowledge level is not typical of your average consumer in their average home somewhere in the world. And I think that's where we have to be mindful of someone like Philip can look after himself. If say on somebody else's family network, they think they've got parental controls and they're being bypassed because the software's changed, that's a different problem set entirely. As for the schools thing, I think we need to be real here. Again, if someone's personal device, say their phone bypasses those controls, fair enough. The school may have a policy, maybe they don't, whether you can use that device in the school. The issue is for the devices managed by the school for use by the pupils. And to just make a polite point, this is a non-trivial exercise. There have been several inquests in the UK where the content filtering was being bypassed for various reasons, which have led to suicide. So this is a non-trivial issue that we shouldn't ignore, because we have different worldviews. But as I say, it doesn't make any difference if you've got unmanaged other devices. That's not what we're talking about. We're talking about the stuff that is offered by the school for use by the pupils in school.
Hi, Medica KO, and I guess I get a special mic. So I'm usually in the security world. I've been a CISO. I'm helping multiple schools right now. What I like about this draft is that it talks about operational reality, and hopefully we'll have choices in terms of what you can do if you're in an environment where this particular option is turned on by default. One thing that I've liked about the IETF, and I've been part of it for longer than I want to admit to, but you're building the knobs that implementers are going to implement. Is it going to be a default or not is going to be the big question in my mind, because the less knowledgeable users are not going to know to change the defaults, right? And I think that's usually the practical answer in, do you want the default to be encrypt, create confidentiality, right? One piece of the security puzzle. Is that what most implementers want to do by default or not? And if so, I've always been somebody that is an advocate for transparency. Vendors are not transparent in terms of what ports are open or what's on by default or not. And I think that's the main question, and why I like, we can standardize everything, and we do. We standardize, up the yin yang. But what I like about these types of documents here is that they explain things, and they will hopefully also show what you can do to protect yourself with other mechanisms. So thank you for your work.
Thank you. And just to perhaps finish on that point, I'll say this carefully, given one of the co-chairs works there. It's worth bearing in mind that going back to IETF 113, the plan pre-meeting was Chrome was about to be shipped with ECH enabled by default and not being user configurable by any user. In fairness to Google, after the meeting, they made an announcement it would at least be configurable on managed devices on a temporary basis. So they did react to that, but originally it was envisaged it would just be switched on, job done, move on to the next shiny thing. Yeah, just agreement to that last point. Let's have more transparency and more user configurability.
Since we're into closing statements, one of the operational realities is that to the extent that this is meant to bypass filtering and, perhaps an authoritative government is the picture in one's head. The operational reality is that sometimes it is the CISO or the sysadmin who is going to deploy the new Fortinet option and say, gee, if you're trying to negotiate TLS 1.3 with ECH turned on, the firewall is going to prevent that. That's an operational reality. Now, perhaps the vision is, okay, in that case, those users will not be able to reach many websites. They're going to complain to their operator, and that puts pressure, there. Just be aware that right now, the general thinking is there will be no fallback, no pop-up, no nothing. If it doesn't work, it doesn't work, because any kind of fallback is it's a vulnerability in some sense. That's almost like a battle that is we're driving toward the place where that battle will be done. I would like us to do so with our eyes open. That's why this draft exists. We want to talk about what are the real world implications. Please take a look at the draft. Please consider joining the drafting party.
On that note, I think we're done. So thank you.
Super nice. Thanks.
Thank you very much. Also, thank you again to everybody who, appeared when I was like, help, I don't have any presentations. And people came along and made presentations. And with that said, everyone start thinking about what useful research and operational presentations you might have for this time in 3 months. Where are we going to be? Thailand? Yep. Thailand, Bangkok. Great.